Hello everyone. Today is the last lecture in this Node.js course. And today we'll speak about OOP, design patterns, and solid principles, which is not related to Node.js directly, though it's just fundamental knowledge about OOP and patterns, though, well, yeah, you those ones can be used in any language, almost every language, and Node.js isn't the exception. So let's start with the OOP first. So why OOP? There are other paradigms, and as you know, the JavaScript is a multi-paradigm language, so you can write functional code, you can write OOP code, any style you want, though the OOP is the most popular one in most of your projects. Maybe in all of your projects, you'll use the OOP. Those are OOP projects, not only for the Node.js, but yeah. And most probably you'll work with the OOP since, well, that's how history formed up. A lot of old code, a lot of new code is written using OOP. My take would be since the OOP is pretty easy to understand and you can find a relation with real life, and for the people not related to your code, you can kind of talk in a code terms with them, with their not being very aware of how things are working. So OOP is quite concrete, though, yeah, and it's easy to understand to people who is not working with the code directly. But that's just my take. That's not the absolute truth. Maybe you'll find some benefits in OOP for yourself. Oh, yeah, and of course the OOP do not bring this huge weight of terminology like functional programming do, though, yeah, so maybe that's the reason also. And now let's talk about the OOP principles. So those are three pillars of OOP. You are all familiar with them, I assume. Just let's recap them. Maybe you'll learn something new from this recap. Yeah, so encapsulation. So, guys, what do you think the encapsulation is? The question for you.
Main idea is privacy, is I guess.
Um, so the access modifiers, right? Like the private, protected, public.
Private,
Yeah.
public, protected.
Well, yeah, that's actually a very popular way of interpreting the encapsulation, though encapsulation is not about the uh, access modifiers actually. It's this principle is more about making the data and the methods which are using this data in one place. So like in your class in one object. So you actually do not need to have the access modifiers in order for encapsulation to exist. The main idea of encapsulation is that you have the bundle of the data and the methods in one object in one class. So and in you can face the encapsulation in not all fully OOP support languages like C, for instance. There are structures as far as I remember, and they kind of have this encapsulation since they group something together, group some methods and data you can use all together without any access modifiers. So yeah, it's important to understand that the encapsulation is actually the ability for you to group the things you work with together. Yeah, so and the encapsulation, in my opinion, is the fundamental of them all. It's the kind of brings a lot of stuff, and in addition to that, you are not able to achieve the inheritance and polymorphism without the encapsulation. Since inheritance is the ability of a child class to have some properties of a base class. Like you can just extend this class in your child class and use the all of the um, base class properties in this child class. And when you do not have the mechanism to group the base class together, then you're not able to extend it actually. So that's why the encapsulation is very important. And well, the polymorphism, the principle is actually stands for ability to override functions, right? Different set of arguments you can use with the same function, with the same function signature. Though overriding the methods of a base class is as well polymorphism. And there are actually two ways of polymorphism, the static one and the dynamic one. And spoiling this for you, the JavaScript supports dynamic one, though let's talk about those types of polymorphism. The static polymorphism is kind of the main difference is when the linking to the function you will actually use will happen. So in static polymorphism, the function would be linked on a compile time. So your code, your programming language is aware of the actual function you are calling before the runtime, so on compile time. And the dynamic polymorphism, it's like the one which is implemented in JavaScript. It's the polymorphism where on precompile time or before the runtime, your code doesn't know which function would it be. And the linkage is happening on the fly, let's say. The exact function is decided on the fly, and that might take some time for your programming language to find the actual function implementation. Though, yeah, so those are the differences. None of them is better or worse than the other one, though they're just different ones. And JavaScript uses the dynamic one. Yeah, so maybe you have some questions about OOP principles. Maybe you have question why abstraction isn't here, since it's a very popular kind of way of describing the OOP with the first principle to be the abstraction. And answering this question, well, it not really, since abstraction is kind of it's present in those principles, though it behind the scenes, since in encapsulation you do not actually, you might not know the actual implementation, so you kind of need to focus on the abstraction. In inheritance, the same thing, you might not know what are the methods of the base class are doing, though you have the interface or the method signature, and you kind of um, go a bit forward from the implementation of these actual methods in the base class. But yeah, maybe some questions on those principles before we continue.
TypeScript has abstract class, right? As I know.
Yeah. Well,
Uh,
yeah. Please
But
go on.
actually, for example, when we define in TypeScript and during hosting, and actually, for example, we hosted our TypeScript app, it bundled everything to JavaScript. Abstract class will lose, right? Or how it happens?
Yeah. So, like you know, guys, the TypeScript is the superset of the JavaScript. It brings some cool features like the interfaces, enums, abstract classes. Though, yeah, it's right that it's all being converted to the JavaScript, and JavaScript do not give you those kind of abstract classes, enums, interfaces out of the box. So it's kind of done on just for ease of use, for you to structure your code. for you to be aware of the kind of which methods this class implements, which values are in this enum, and it's not the syntax sugar as async await, for instance, but it's just something for you to simplify the way you write your code, since you do not need to guess like you do in JavaScript. If your function expects a square, it's no way for you to give this function a circle, since it expects the square, and TypeScript will give you an error and won't compile the code. Though TypeScript just simplifies your life, but it do not extend the JavaScript in any way. So the abstract class will be transpiled to the JavaScript. I don't quite remember the way how it's been transpiled, but the main benefit you get from this abstract class is that like with all abstract classes, you are not able to create the instance of this class, and TypeScript ensures that your code do not do this in any of your file. So yeah, in the end of the day, it will be JavaScript, and you can use the JavaScript hacks, and you actually might receive something you not expect, since under the box it's JavaScript. Though yeah, if you write in the TypeScript in a proper way, you won't see those issues. Hope that answers your question.
How
Yeah,
does
thanks very much.
how does TypeScript interfaces work? Like they create instance of an object, and then other object interface inherit prototypes like in JavaScript, or how does it work?
Not really. TypeScript is just interface is just a TypeScript thing, and I'm not really sure it's even compiled to JavaScript. Though the interface in TypeScript just looks at your class, and since the JavaScript is the most OOP language out there, since everything is an object, and even your class has a prototype, before it's been created, right? When it's just a class, it's just an object with all the properties in the prototype. And when you implement the interface in JavaScript class, the TypeScript looks into this object prototype, and if it doesn't find a property you have declared in your interface, it would give you a TypeScript error. Though what's important that there are some directives in the TypeScript, like TS no check, which would disable all the TypeScript errors, and you might implement the interface, though not fully implement the interface. And when you have this directive enabled, you would be able to run your code and nothing would be broken. So TypeScript do not brings anything to the runtime. It's main purpose to give you hints on when you write code before the runtime.
Okay, thanks.
Okay, nice. So when OOP is done, let's talk about the design patterns. And yeah, actually, what design pattern is. So as you know, programming is here for quite a long time. And some of the programming programs are so popular that they have known solutions for them. And those solutions actually the design patterns. So the design pattern is just a solution for your problem. Since and they always should be a solution to a problem. And if you do not have the problem which specific design pattern solves, then you maybe shouldn't use the design pattern, since design patterns introduce some add some abstraction layer to your code. And when you use the design pattern, you should be aware that your code might not be as readable as it was before, since it won't be only focused on accomplishing the specific thing you want this code to accomplish, but rather than that, it would solve some structural problems and etc. So it's really a bad practice to use the design pattern when you do not have the problem which the specific design pattern can be used with. And it's a good practice to solve the problem with the design pattern, since the problems are the known problems and the solutions are known as well. And actually, when you give a name of a design pattern to your colleague, to other programmer, he'll understand what you mean, and you do not need to describe your solution in detail, since those design patterns are kind of some snippets you can use to solve your problem, which is in your project. And to bring some clarity, let's go into the specific examples and yeah. So there are 3 types of design patterns. The first one is the creational pattern, and the creational patterns are actually focused on solving the problems with object creation. Maybe to create the object, you need to introduce a lot of dependencies. Maybe there is some complex logic when you create the instance of a class. And creational patterns can actually solve those problems for you, since they provide a simple solution, maybe not so simple, but some solution which would make this process simpler, and your code would be more maintainable, though might not be more readable. Then the structural patterns. Structural patterns should be used in kind of in a situation when you have a huge classes structure, like a lot of classes extend other classes, maybe just you have a lot of classes which are related in some way with each other, though the structural patterns help you to solve those kind of problems. So they introduce some new classes, they might change the way you extend classes, and etc. All the structural related problems. And then we have behavioral patterns. Those patterns are related to kind of changing the behavior of the specific class with some input data, according to the input data. So behavioral patterns are more related to the logic than any other things. So those are the 3 main types of the design patterns. And actually, there are already a bunch of patterns. This specific screenshot was taken from the Refactoring Guru, the site where you can read about the design patterns. All of those patterns are provided, you can read about them on this site, though it's not the complete set of patterns. There are much more to that, since there are a lot of problems and a lot of solutions to those problems. So it's just, I would say, the most popular ones. And yeah, maybe when you have spare time, you can read about them. But for now, we'll talk about 3 specific patterns. And the first pattern is the strategy. So the strategy is the behavior pattern because it changes the implementation. Kind of it might change the implementation. It might pick the correct implementation for a specific case, but you can treat it like the actual strategy. Like it's pretty straightforward, and the example for the strategy can be like you might have the your application has a way to take the money from user, and you give the user some options, some amount of options how he can spend, how they can spend their money. They can spend it with the credit card, maybe by cash, maybe by cryptocurrency, or just any, yeah, maybe PayPal. And all of those strategy have different implementation. There is different logic to implement the specific paying method, though on a bigger picture, they're accomplishing the one thing. They charge money from the user, right? So ideally, the code which is responsible for charging money should be the same for all of those options. The only difference should be related to this specific option. And what you can do, you can create the specific class for each paying option. Maybe the class for PayPal, for the class for the credit card, the class for the cryptocurrency, and they all will share the same interface. And on your code, which is actually responsible for charging the money, that would look like you just call one function or one class, which would give you the strategy according to the option the user has chosen. And you'll just call the execute method, and the money will be charged. And you don't actually need to be aware which option they have chosen from. You just can focus on implementing those specific options isolated from each other. So this way of using the strategy pattern is a very beneficial way, though, as I said, you see this diagram, right? You need to implement the whole diagram in your code in order for strategy to work, instead of just calling the paying system directly, right? So it brings some overhead in your code, and it might be harder to read, since for sure it would be split it in separate files, so you need to jump in and out. So, but yeah, this way of putting things makes your code very easy to maintain and very easy to debug. The next pattern would be structural pattern adapter. So let's imagine you have a service which receives the JSON data, but your client code receives the data in XML format. So your client code cannot call the service code directly, since because of the data format mismatch, since XML is not JSON, and when your service method is written to work only with JSON, it won't work with the XML. So you need somehow to adapt your code. You need somehow to convert this XML to the JSON, and adapter can help you with that, since adapter would be the one which is responsible for this conversion. So the adapter would have just some function which would convert the XML to JSON, and you can, for instance, extend this adapter class in your service class and kind of override your method you wanted to make adaptable with the you can override the method you want to work with XML now. So the first would be called the adapter method, and then would be called which would convert the data from the XML to JSON, and then it would be passed to the service method. Or you can just create a mapper class, for instance, because this specific example is kind of, you can implement this in the languages which support multiple inheritance, the JavaScript, not the one. So, well, you cannot extend multiple classes in JavaScript. So you can create the mapper class, for instance, which would be responsible for converting your data from XML to JSON, and later on call the service method with the JSON data. So this pattern is structural, and it really, because of you need to create a new class kinda and use this class in different classes. And actually the benefit of the adapter class is that you can create multiple adapters which would not be dependent on any of your existing classes, and you can actually reuse them in many classes since they do not bring a lot of dependencies, and they can be interchangeable. So that's the problem structural patterns solve. They kind of make your classes structure to be more simple to use. And then another observer pattern, another behavior pattern, sorry. It's the observer. You're already familiar with the observer since you've used the event emitter in Node.js, and you kind of know the drill. So yeah, actually, observer pattern simplifies the way of your application to react on any changes. So that's why it's the behavior pattern. It introduces some algorithmical features in it. So JavaScript is pretty easy to implement since the event emitter pretty much does everything for you. But like ideally, if you do not have event emitter for some reason you don't want to use it, you need to have the class which has all the events and which kind of is able to notify your event manager, which would be responsible for calling the listeners when something happened in your code. And when your event listener is notified by the editor class, then it would notify all the event listeners which are stored inside of the event manager class. And all the event listeners share the same interface. And actually, that's all you need to know, since you do not need to know about the listeners' implementations. They can do everything they want. Like you do not matter at this point. You just need them to share the same interface. And of course, you can add the new event listener with the subscribe or delete the existing one with unsubscribe. And I guess that's one pretty easy since you have already used the observer pattern. Though what I can say, the observer pattern is not pretty much widely spread on the backend, maybe only in the event-driven systems, though in your classical backend application, you might not face it, which is different because the strategy and adapter you can find almost in every backend application, though Observer has some exceptions since there are some system requirements for Observer to be viable and to be not harmful to use, right? So, and yeah, actually it's used a lot on the front end in Angular, for instance, since everything is related on the events and they propose the reactivity. Actually, all the front-end framework do. So yeah, it's more related to the front-end, though it can be used in the backend in event-driven systems. Yeah, so that's it about patterns. Maybe some questions. Okay, and if no questions, let's go on. And now the solid. Guys, have you heard this abbreviation? Solid, do you know what it is?
Yes.
Nice. So it would be
L
easier.
is for
It's
list.
like a list. For example, S stands for single responsibilities, and next one is open close.
Okay.
Is for
Lisco.
subscription or don't remember the name. Lips or whatever.
List of substitution.
Yeah.
Yeah, let's dive deeper in it. So yeah, those actually what this abbreviation stands for, take the first letter of all of those principles and you'll get solid. But yeah, actually, as I said, programming was here for a long time already, and all of those principles were isolated from each other until some clever guy decided, well, those principles work isolated from each other, so why don't I form a list which would include all of those properties, all of those principles which makes your code maintainable, which makes your code readable and easy to debug and all other nice stuff. And he kind of picked those 5 principles and now it's solid. So they were existing isolated before solid was created kind of, but now we know them as solid, and it's pretty easy way to remember, since solid is the word and it means something. So yeah, and you know that you should follow some 5 principles for your code to be good, fundamentally. And yeah, that's really the case. Actually, when you follow all of those principles, your code would be flawless, though you won't. Spoiler, you won't. And it's very important to know when you should not follow the solid. And there are such cases actually. And yeah, but for now, focus on following the solid, since before before moving forward from the classics, you should learn the classics, right? So let's start with the single responsibility principle. This principle stands for that one function, module, class, system should do only one thing, right? So it's not related only to functions, to classes. It can be related to the whole systems, along with those all of the 5 principles. It's not about how you write the code, but it's more about how you form your system, how you architect your system, though the smallest part of this whole process is writing the code. So, and those principles are can be understood on the code level. And when you understand, and when you fully understand those principles, you can use them on the higher level. So single responsibility, as I said, one thing responsible only for one thing, and it shouldn't do anything more than one thing. Actually, yeah, sorry, one more thing. You can read well, I don't quite remember the clean code. It was for clean architecture, and Uncle Bob actually describes those principles very well in his book, and my skill is not sufficient enough to describe them in the same manner, though I'll try, guys. Some basics you'll know, but if you want to go into details, I highly recommend to take a look at how Uncle Bob approached them in clean code and clean architecture. So let's start with single responsibility. So kind of we have class person, and this class has some fields related to the person and the format method. Well, let's do some trivia. Guys, what do you think is wrong in this code snippet? What do you think violates the single responsibility? Well, we are tolerant to other programming languages, so C# is not very bad. But yeah,
Java?
Java? No. The wrong thing is the format method. The format method is wrong, is violating the single responsibility principle, because this format actually do not bring anything to the person class. And of course, when you think about the person, the format is the last thing you kind of recall, if you recall this kind of thing. So actually, this format method looks generic enough to be used with any other class other than person. So it actually a huge mistake that the format method is inside of the person class, since it should not belong here. There is no relation between person and the format. So what we can
Isn't
do,
it override of generic format? Couldn't it be like generic toString and we change toString logic for our use case for person specific?
well, not quite. If you think about it, taking a look at the first fields, first four fields, you understand that the person class is only storing the personal information, kind of. But for some reason, there is a format method in it. And this format method is not related to the personal information. And since this person class is responsible only for storing the personal information, the format class is something new, and you can say that class person is responsible for storing the personal information and formatting the person. And when you need to use and in this sentence, that's kind of already a violation of single responsibility principle, because yeah, person shouldn't be responsible for formatting any data structure. So let's take a look at how we can fix this. And instead of keeping the format in the class person formatter, we can move it to the separate class. And that would be the good thing to do, since now the person is only responsible for storing the personal information, and the person formatter is responsible for only formatting the person, right?
Can you recognize it as a design pattern? For example, I just thought that during this design pattern overview, for example, class person is a structural or creational pattern, and the person formatter to be just behavioral pattern. Can we
Not
recognize
really.
this way?
Not really. Well, it doesn't solve any problem, actually. It just now your person class is not violating the principle. And you can, of course, use the design pattern to get rid of those switch cases, since this function can grow very big, but it's a bit out of the scope, and it's not the design pattern. It's just you're moving the code which is not related to one class to another class, and it's fundamentally a good practice to do. And it doesn't make your code to be less readable. It just improves how your code is maintainable, and how easy it is to add the new features, for instance. Because maybe you might format not only person, so you might have the common logic between different formatters, and when the formatter is inside the person class, it would be hard to accomplish. But with the person formatter being the separate class, it's pretty easy to kind of form group of formatter classes and include the person formatter in this group. So yeah, it's not the design pattern, and all of those principles are not the design patterns. It's kind of a way how you can approach your code and evaluate whether it's good to maintain or not. And yeah, maybe it's a good exercise to take a look at your past homeworks and pinpoint such things which violate the patterns, and you might have the greater understanding of the solid itself. So yeah, since you always need to ask yourself, do I remember those principles? And if I remember, do I violate in any of them or not? So
Thanks.
yeah. Any more questions about these principles since we are moving to the next one? Okay, open-close principles. So this principle states for classes, functions, etc. Should be opened to extension, though closed for the modification. So ideally, this code is violating this principle since you need to extend this, you need to modify this code in order to add the new switch case. And this code violates this pattern as well. Maybe some ideas why does it violate it. So yeah, let me describe the code. We have the write function here, method, sorry. And we have some message here. And depending on the operating system, we write to different places. So do you see the violation here, guys? So the violation would be, well, according to the operating system, we have those if statements. And when we need to add another operating system support, we need to modify this write function and add the new if statement, maybe remove the already existing if statement. Maybe we should adapt this function to work without the knowledge on the operating system. And it really violates the open-close principle since we are modifying the source code, but we shouldn't modify it. We should only extend it. And ideally, we should get rid of all of this if logic. Since, yeah, your function can grow very big. And in this specific case, you can have a lot of cases in the switch case, which would be very hard to read and not very maintainable. So to fix the violation, we can create the interface iWriter, and each class which implements this interface, sorry, each class that implements that interface would write to only one dedicated place. So instead of doing this, we can wrap this, we can move those write to console and write to error console to its own class. And we can have the array of such classes, and we can call all of those functions in array. And actually the logic to decide whether we should write or shouldn't will be inside of this class. So our write function, our write method do not requires to be modified anymore, but we can just add an entry in the writers array, and all of this all of the new ways to write or not write would be added automatically. And yeah, this principle is very hard to master, I would say, but it's when you do so, your code would be very maintainable, and you'll need to make much more or less changes than you have to do when you violate this principle. So any questions before we go to the next principle?
I have a quick question. So if we have, for example, two statement and two option, so this violates this principle, or it is any other thing I just missed?
Well, yeah, that's a good question. That's actually a good question because you shouldn't blindly follow all of the principles, as I said, and ideally, yeah, you can somehow put the words in that way that would be a violation, though there are many situations when you have only two options, like maybe your application do not support anything more than those two options and won't be support those options, like what the example should I give here? So maybe, okay, maybe it's just left to right, right? And you have a function which would pick a direction, and there are only two conditions always. There is not the third option. You can only choose only between left and right. And in this case, when you would have the if left or if right, that's okay for me personally, because you won't have the third option. You need to add the new option. So you need to understand whether you need to extend this code actually. And yeah, so it's not just blind following of those principles. But yeah, so, but you can still use this approach, and this won't bring any overhead to your code. And if you're not sure whether there will be the next option or won't be the next option, then why not just do this approach right away? And this would make things potentially easier for you. And if there is no option, well, you've already implemented that. And it's fundamentally a good practice to follow solid patterns. So you're not mistaken by doing that. But it's not always required to do.
Thank you.
So your favorite Liskov substitution principle. This principle stands for, so when you have the base class and the child class, potentially in all of the places where you're using this child class, you can instead do the substitution and use the base class instead, and your application shouldn't fail. So yeah, that's pretty complex. For me, it was hardest to understand personally, but let's take a look at the example, right? And do you see what's wrong here? Where is the violation? Okay, so the violation would be, so let's go to the code. We have the class task, which is the base class for the project task. And we have two properties, like the status property, and we have the close method. And the close method just closes, puts status to closed. And then we have the project task, which extends the task. And it overrides the close method from the base class. And instead of finishing silently, it throws an exception. So what the problem here? In all of the places where you expect the task class, you might receive the project task. And the task class do not throw any errors. It just finishes silently. Just do one simple thing and that's it. You safely call the close method, and suddenly you receive the project task, and your code isn't complaining. It's the project task is a type of task, and it's true. And then you close the task on the project task, and you receive an error, which you well, that's a bad thing. Your application crashed. The company you're working for lost $5 million, and you need somehow to give them back those $5 million. And if you have followed Liskov substitution principle, you shouldn't have done this, and you won't be owning $5 million to your company. Though the issue is now whenever you use the task class, you need to wrap the close call in a try catch, which is not a very good thing to do since it can be used in any other places. Maybe your colleague would go to your code and just call the close method right away without wrapping it in the try catch, since the task class is not throwing an error and he thinks you're following the Liskov substitution principle, but you're not, and you receive an error here. And that's the violation, since you're now not able to interchange the task and the project task, and vice versa. So what we can do in order to fix the violation, we can add the additional method canClose into the base class, and now whenever you call canClose, whenever you use the task project and want to close the task, you need to call the canClose, and if you receive canClose true, then you can safely close the task. And if you're not, then, well, actually your code do not give any guarantees that it won't fail. And now you can, before calling the close right away, you can call canClose, and if you can't close, then you shouldn't. Or if you still wanna close, you can just wrap it in try catch and expect an error, since, well, you can't close. What have you expected? So that's one is not pretty straightforward, though it comes with the practice, but you need to be aware. You need to remember one thing. Whenever you use the child class or the base class, you should be able to interchange them, and that should not fail. And when you kind of do this exercise, you can find the weak points in your design. Any questions? Okay. The next principle is interface segregation principle. And this principle is focused on whenever you use the interface, you should depend only on those fields you are actually using, and you do not need to keep the overhead of the fields you're not using. So let's take a look at the example. Here we have the interface of a smart device, and this interface saying that whichever class which would implement this interface would be able to print, fax, and scan. And here we have all-in-one printer, very expensive one, and it's indeed capable of printing, faxing, and scanning. So can you find the violation here?
So fax and scan must be different interfaces or
True.
stuff like this.
Yes, that's the correct answer. Since, well, as we have learned about the single responsibility principle, right? The person class should not be responsible for formatting, and the person class was responsible for storing the data and formatting. And the same thing with the smart device, it's responsible for printing and faxing and scanning. And when you can find the end, yeah, that means you're violating something. And as you can see, those principles are depend on each other, and they can work all together. They're not completely independent. They have some influence on each other. And this principle, interface segregation, is the good example for that, since indeed you can have the economic printer, which is capable only of printing, right? And those methods are throwing an error. And that's a bad practice to throw an error on the methods which are defined in the interface but not implemented. So yeah, what you can do instead is to define 3 simple interfaces, and all of those 3 interfaces will be responsible for one thing, and you can combine those interfaces to pinpoint the exact behavior you need. So you can have the economic printer to be capable of printing, and you can have all-in-one printer which is capable of everything. And the code which would use those things would benefit as well, since, for instance, you have function print and you receive the content and the printer, and instead of expecting the all-in-one printer interface, it can expect just iPrinter interface, since it do not need to fax and scan. So this principle is not related only for the interfaces. In the TypeScript, you can declare types, and the main idea of this principle is to keep things as modular as possible, and in case you need some additional properties, you can always extend the existing interface. And the same with the types in the TypeScript. You should not build the very huge types and just use them everywhere, since these types are often would have some optional fields, and they are optional since you don't need them, though the type insists on them to exist. But when you follow the interface segregation principle, you can make your types granular, and you can expect in your function just a smaller type. And it's fundamentally as well a good practice to do, since you want to keep things as modular as possible for them to be reusable. Yeah, any questions about interface segregation principle? Okay, and now the dependency inversion principle. So dependency inversion principle teaches us to depend on the abstraction rather than the something concrete, and the interfaces can help us with that. And yeah, so let's take a look at the manager class. So the manager has worker, and manager is actively using this worker. And please notice it's the specific worker class, which is only one class. It's not the group of classes, it's just one class. And yeah, actually manager can manage, and you can set worker in the manager, but it will be always the type of worker, the instance of this specific class. And there is a super worker now. So can you find the violation here? So the violation would be that we are expecting the specific worker in the manager class, and when there is a super worker, which is actually the same worker as this one, and it's also is capable to work, but for some reason manager can't use this super worker for some unknown reason. So, and it's actually a violation of the interface of dependency inversion. So what we can do instead, we can declare an interface, and now our manager class can depend on something which is not existing on the interface, though actually now class manager do not need to know about which worker this class is using. They do not they can use anything which is capable to work. Specifically, that what the iWorker interface is doing. It's saying that whoever implements this interface would be able to work, and that's the only thing which is important to manager. So it can expect anything which is able to work because the main purpose of manager is to make worker to work. And when we depend on the interface rather than the complete concrete implementation, Now we can declare multiple workers. So it can be a worker, super worker, maybe lazy worker, but they'll have the common thing, which would group them into worker group. It's the iWorker interface. And now the manager can use any of the worker. And it makes your code more maintainable, as I said, and fundamentally a good practice to follow, right? Since you can declare multiple classes with the iWorker interface, and expect this iWorker interface to be present. But if you expect the concrete class, then yeah, your code won't be as flexible and maintainable. And that's it. This lecture was quite short, and that was the last lecture. And the good news for you, there is no homework for you. Well, only the final project, but it's not after this lecture, so this lecture brings you the good news, no homework. And yeah, maybe some questions.
Are those principles really used in like programming world, or they are just for knowledge?
Those principles are used. They are widely used, since those principles they just make your code very maintainable, and it's really important because on the real project, you always receive the new feature to add something new, maybe to extend some existing functionality. And if you won't follow those principles, it would be very time consuming, and your code would be very flaky and hard to extend. But when you follow those principles, your code is easier to extend, so you can implement your feature quickly, and the rest of the application wouldn't be affected, ideally. So it's really a good practice to follow those principles. They're not some kind of the textbook example. They're commonly spread in the good code bases, and yeah, actually not very commonly spread in bad code bases, I would say.
Okay, thanks.
Well, if no more questions, then that was it. Theory wise from this course. Hope you enjoyed this course. Hope you've learned something new, not only about Node.js, TypeScript, but fundamentally about the programming, maybe some new ideas. So I wish you a good luck on your final project, and yeah, keep up the good work, write the good code, follow solid principles, and you won't need luck, I would say, if you do this. But yeah.
Thank you so much.
Thank you.
Yeah.
Thanks.
Thanks
Thank
very
you.
much.
Yeah. Okay. Bye-bye.
Bye.
Have a nice
Bye.
evening.
Have a nice
You
nice
too,
day.
and
Goodbye.
thanks, and bye.
Thank you.